like everyone else, I've been watching the petition, the election petition going on at the Supreme Court, and yeah, it's been really interesting hearing all the arguments from the lawyers. And one of the interesting things that came out in the case was the error adjustment regression formula that was presented. And yeah, because I like data and stats, so I thought I would try and then test that. So what was presented in the course was a linear regression model. So they're basically saying there was a linear relationship between Uhuru's votes and Raila's votes. So what I did is I just got back. I uploaded the data from IEBC, and what I'm just going to do. So I'd already done some things. So like I'm just going to select all the cases, so all the results, and say okay. So if I go to the data view, I've got, so that's the counties, that's the registered voters, and I've got all the results by all the candidates. And then, yeah, I uploaded all this data from IEBC. So, yeah, I'm using all the, I think 49, so I've got the diaspora and prison, so I've got all the counties there. So, they're saying there's a linear relationship between those two votes, and I've tried, I've tried looking at a few models. I couldn't establish any strong relationship between those based on a regression. So one of the things I did was use SPSS curve estimation. Clear this. I'll tell you more about this later. So basically, in the regression model, they're saying you can predict Uhuru's votes based on Raila Odinga's vote, and they're saying it's a linear regression. So I could have done a scatter plot and checked it visually for any relationship, but I'm just using sort of a shortcut to check whether you can fit a linear model. To try and check the relationship between those two. So I'll just say okay, and so I've run that and see I've got all the cases, all the 49 counties, and that's the linear regression model. And this SIG here is a test of statistical significance. So it tells me really the model is not statistically significant. And another good way I was actually going to look at is the R square. So we have a really low R square of 0.02. Yeah, so that straight away shows me we don't have really a linear relationship between the two. Yeah, but I'm not totally discounting the evidence that was presented. But I've done what a statistician should do. I don't have a PhD in stats, but yeah, so their model exactly had what was trying to model similar relationship. You had Raila Odinga as the independent variable and Uhuru Kenyatta's vote as the dependent variable. But yeah, they had a really strong positive linear relationship between the two, which I failed to establish using that simple model. So in my thinking, I was just saying, if I was in IEBC and I wanted to do something, what would I do? And I thought, okay, yes, we already have the number of registered voters, and I think that's a good basis to do if we were going to try and adjust results. Yeah, I remember the tyranny of numbers. Yeah, so I think what I did was try and sort of do another regression, but based on the tyranny of numbers, so the number of registered voters. And of course, we know there's a very huge increase in the number of voters if you compare 2017 and 2013. Yeah, so yes, I've got it out this summer, but I'll not go to that at the moment. So the first thing I'm doing is just to do the regression based on the counties that we know uh, we expect, say, Uhuru to win, and not hold someone on everything. So what I'll do, I'll just select cases and I'll do a condition. So I'm saying I just want the cases where Uhuru's votes are greater than Raymond's votes. So for that, I'll just say okay. So that will give me just a few cases. And if I go back to the curve estimation, and this time I want to predict Uhuru's votes based on the number of registered voters. So that's again the tyranny of numbers thing that I'm trying to do there. So I'll just click OK. So I have a model. It's a linear regression model. So it's trying to estimate the curve, and straight away you can see my R square has gone from 0.002 to 94.9%. What this tells us is that 95% of the variation in Uhuru's votes can be explained by the number of registered voters. So that's a very strong R square figure over there, and you can see our model is now statistically significant. Yep, and if you look at the curve, so there's a really strong, in fact, the curve that's presented in the Supreme Court, the scatter plot is yeah, exactly that, except it has the relationship between Uhuru as a dependent variable and Raila Odinga down there as the independent variable. Yeah, but for some reason I couldn't arrive at the same results. Yeah, so yeah, but I'm using the election results data from the IEBC. So I've sort of done a shortcut. If I was doing a proper regression analysis, I should have started with the scatter plot to just see if there's a linear relationship, then run a regression model, check the assumptions, the basic assumptions that you need to ensure are not violated. But I've just started with the curve estimation to see if I could estimate that model. So what I'm going to do now is I'm just going to run an actual linear regression. So I've got, yeah, I'm trying to predict Kenyatta's votes based on, yeah, tyranny of numbers. And I just want to see, yeah, model fit, stats, and yeah, I'll probably want to see if we have any collinearity issues. Yeah, so I've checked that. Darwin Watson statistic, continue, and I'll just have a PP plot of residuals against predicted, just to see if we meet the assumptions of linearity and homoscedasticity. Yeah, so all done, check, go, and that runs. So we've already seen the model summary. So there might be a positive correlation. We want this to be really close to 2, but yeah, we're not really concerned about it at the moment. So we see our R square is, yeah, 95%. Yeah, so that's similar to other results we got from the curve estimation. So we're going to use this coefficient. So in the Supreme Court, so their constant was, I think, 183,546, and it was positive, and they had so their beta value was 1.204. So that's just slightly different from what we get if we use the registered voters. Again, I could not duplicate the results. So we just count here. So we are now checking for the assumptions. So one of the assumptions is whether our variables our DV are normally distributed. So we can see they are normally distributed, so which is not so bad. We look at the PP plot. We've got values both below and above the diagonal line. And if we look at, again, that scatter plot of standardized residuals against predicted values, I'm just going to add a regression line over there. Close. What we want to see is the residuals distributed exactly the same way above and below. And we can sort of see that it's not. So this just basically, we've met some of the basic assumptions for a linear regression model. So what we need to do now is to come back to the to our coefficients back here and plot them onto a spreadsheet. Yeah, so, and I've already done that over here. So this is predicted. You can see that's our beta coefficient. So 0.764705. So which is that? So it's 0. Yeah, so that's the exact value, 0.764705. And that's our constant. So it's 2287. I'm just going to copy that. I'm sure it's correct, but I'm just going to copy that over here. And it's minus. So I'll just get rid of the other negative. Yeah. So I've plotted all those, and so what I have here is I'm just testing the accuracy of this model. So and I've only pick the minus to plus 10%, and so what I've done is I've plotted those on this chart over here. So I've already done the chart, but I'll just show you what I did with the chart. So basically, I've picked up the predicted, and that's the actual, that's the predicted, and I just come to data. I think it's inside a column. Yep, so I've got a column chart over there, and yeah, just to get rid of, so I'll just click on that and say select data, and series 1, if I edit that, I think series 1 should be, yeah, so I can just add this series name over there. And series 2 is the predicted. Yeah. And there you go. And over there, I'll just pick the actual constituencies that I've used. And yeah, there you go. You have the chart. So just pull it back to make it prettier. So it's exactly the same chart. I've just done that earlier. So you can see, yeah, our predictions are really close to, yeah, in fact, in cases like in NAND, you almost have the same figure. If we took account of, so here we haven't taken account of all the rejected votes in this votes. That's why you've got some differences. But I think if we took account of the other rejected votes, then we would have, yeah, even much closer results. So the other interesting thing I did, again, just to test, so I've added another column here with the Supreme Court regression model. So their model was 1 point, so that's the constant, which was 183546. So I just wrote that from listening to the petition on YouTube, and then yeah, so that's the regression model. Yeah, and if I plot that in, so I've added that as well on. Yeah, let's show you how I did that. So if I come back to the design, then I can add another data. So the series I've and then the data is just that range over there, and you can see straight away. Yeah, we have some really big differences, especially in Kiambu. Where, yeah, in some instances, it's not as bad, but yeah, it's not as consistent as the model that's based on the registration of numbers. So, in a nutshell, you can use regression model to try and predict a variable based on their relation with another variable. So there are a few assumptions you need to make sure are not violated. And yeah, that's it for today. And again, yeah, I'm just trying to test the numbers. I'm not saying anyone is right or wrong in anything. I hope you enjoyed that. And yeah, we'll talk to you again next time. Uh, Bye. Do, 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 do. Stop that.